Okay, hello. Welcome to this lecture on prerequisite mathematics. So we're going to go over the basics of algebra, calculus, trigonometry, physics, chemistry, maybe some biology. So we're going to try to explain for people who don't know a lot of math to people who know a little bit of math and people who just need a refresher. Some mathematics review. So first of all, we have algebra. Now, what does algebra mean? Algebra means numbers, variables, and equations. So, numbers, variables, equations. And what you want to do is then solve these equations. So an example is 10x plus 3y plus 4z equals a. So in this isn't, why is this an equation? Because of the equal sign. Equation. So because we have an equal sign, it means we have a left side and we have a right side. Left, right. And they are the same because it's an equation and it says equals. Another form of equation is for it to say greater than, which means this side is larger, or less than, which means this side is smaller. So you can have greater than, less than, you can have greater than or equal, you can have less than or equal, or you can just have equals, or if you're doing a proof of a law, you have super equals. So this means absolute truth when you have super equals. So that's an equation. You have the left side is equal to the right side. And then what can we do with an equation? So here's a law. What we do to one side must be done to other side. So you see here we have what we do to one side must be done to other side. So let's do an example. So here we have an example of 10x plus 7 equals 20. So we say 10x plus 7 equals 20. You want to separate variables onto one side. Separate variables onto one side. So we need to move this term over there. How do we do that? We subtract 7 from both sides. So we say 10x plus 7. That's the left side. Now we're going to go minus 7 equals 20. That's the right side. Now we're going to say minus 7. So we end up with 10x equals 13. Now, we have the variables on one side, all the x's, and we have the numbers on the other side. Now what you want to do is to further solve, we want to solve for 1x. Okay, so what does x? So example, x equals, okay, so 10x equals 13. How do we get to 1x? We divide both sides by 10. 10x divided by 10 equals 13 divided by 10. The 10s cancel out, and you get x equals 13 over 10, which equals 1.3. So x equals 1.3. We started off with 10x plus 7 equals 20, and we end up with x equals 1.3. If you have something a little more complex, like 5x squared plus 10x plus 10 equals 0. This is a quadratic equation. Why is it quadratic? Because the exponent is to the power of 2. So the first thing you want to do is factor. So when you factor, you want to try to turn it into something linear. So the first thing we can do is take out 5. So 5x squared plus 2x plus 2 equals 0. And then we divide both sides by 5. 5, which leaves us with x squared plus 2x plus 2 equals 0. So this equation, x squared plus 2x plus 2 equals 0, is the same as this equation, 5x squared plus 10x plus 10 equals 0. But maybe we've lost some data because we lost the 5, we divided it by 0. So but we can always scale it by however much we want to scale it by. So we can always remultiply both sides by 5. But we have this. Now, when you have a quadratic equation, there's two ways to factor. There's factor by guessing, and there's factor by quadratic formula if you can't guess. So the way you guess is you take this multiplier, which is 1. Then you take this number, which is 2. And then you cross multiply all the possibilities. So the possibilities are 1, 2, and that's about it. So, is there any combination of 1 and 2, either plus or minus, that will give you the middle number, 2? And the answer is no, because if you do 1 plus 2, you get 3. And if you do 1 minus 2, you get -1. Or if you do 2 minus 1, you get 1. And if you do 2 plus 1, you get 3. So the middle term has to be either 3 or 1 or -1. But it is 2. So it's not factorable. Once again, you take the variable, the number in front of the x squared, and you take the number at the end, 1 and 2. And is there any combination that will give you the middle number? No. So let's do another example. What if we had 2x squared plus 6x plus 3 equals 0? So that's our equation. Now we take this number, which is 2, and we take this number, which is 3. I'm going to do plus or minus. Oh, crap. Wait a minute. Wait a minute. 2x 1 x plus 3 2x plus 3 x plus 1. Yeah. We can either get to 5, or we can get to -1, or we can get to 1, or we can get, we can't get to 6. So we can't factor this either. What if we had 2x squared plus 6x plus 4 equals 0? So you take this number, which is 2. You take this number, which is 4. Now we know that 2 plus 4 equals 6. So we can factor it. And the way the factor always works is you have an x plus minus and then a number in 1 brackets. And that's multiplied by x plus minus and another number in brackets. And just guess around with it. So Because you know when you expand it, you go this number times this number, and then you do this number times this number, and then you do this number times this number, and then you do this number times this number. And you add them all up together, and when you're multiplying each of them, you remember what their signs are based on what the signs turn out to be. Two positives are a positive and a negative is a negative, and two negatives are a positive. So just guess around. So if I say, if this is 2x, then this has to be 1x, because for the first number, 2x squared, 2x times 1x equals 2x squared. Okay? Now, everything is positive, so chances are we don't have any negatives, because we said earlier 2 plus, is this a 4? 2 plus 4 is 6. So we got to put two numbers that multiply to get 4 is the last term. So that's either a 2 and a 2 or a 1 and a 4. Because the last term is this number times this number. So I mean, let's try plus 4 and plus 1. Now, what do we get? We get 2x squared, and then we do this number times this number, plus 2x, and then we do this number times this number, plus 4x, so that's our plus 6x, and then we do this number times this number, which is plus 4. So 2x plus 4 in brackets times 1x plus 1 in brackets will give us 2x squared plus 6x plus 4 equals 0. And that's how you factor. Now the next step to go from here would be what does x equal? So what x equals is this bracket becomes 0, because then you have 0 times something equals 0. And both sides of the equation would be 0. Or you make this bracket 0, because then you get 0 times something equals 0. So 0 and 0. So 1x plus 1. How does that equal 0? X has to equal negative 1. So you get negative 1 plus 1 equals 0. This bracket, 2x plus 4. How does that equal 0? X equals negative 2. Because you get negative 2 times 2 is negative 4. Negative 4 plus 4 is 0. So x equals negative 2 and x equals negative 1 are the answers to this quadratic equation, based on first factoring and then setting the brackets to 0. Okay? That's in essence algebra. Now we're going to have to go over calculus and trigonometry as well. Now, if you can't factor it like this with guessing and factoring, you can always do the quadratic formula. I'm not going to explain it here. It's basically a formula. When you put an equation into this form, all you do is you have a formula. You say x equals, and then you plug in this number, and this number into the formula. It's all numbers now, but it's a mess. And then you type it into your calculator, and you will get two answers. X equals a decimal long answer, and x equals a decimal long answer. but that will be the answers. It might be even real or imaginary, because it might be the square root of a negative number, which is imaginary. But you will find 2 answers for every single quadratic equation. Why is that important? Because it leads to calculus. So that was linear algebra. Now we're going to get to calculus. And what calculus all about is about graphing. So it's about graphing. You have y and x. That's the axis. Now you can have a line like this, which is simply x equals y. Because at 1, when x equals 1, y equals 1. When x equals 2, y equals 2. What if you had x equals 3y? That means at x equals 1, y would be 1/3. So that line looks like this. X equals 3y, x equals y. Because when you set this side to 1, for this side to equal 1, it would be 3 times 1/3. And you get 1 equals 1. So when this is 1, x is 1, y is 1/3. 1/3. So that's x equals 3y, and this one's x equals y. And the last type of graph we have is parabolas. So something that looks like this. And that is x equals y squared. Because when x is 1, y is 1 squared, which is 1. When x is 2, y is the square root of 2. But every time you have a square root, it can be positive or negative. Because when you take this positive, negative, and you square it, you get equals 2. So when x is 2, you have y is, sorry, this is not x equals y squared. This is y equals x squared. The y is usually on the left and the x's are on the right. So y is on the left, x is on the right. So when y is 2, x is plus or minus the square root of -2. Plus minus square root of 2. Plus minus square root of 2. Because if you square this, you get 2. So this is the plus side, and this is the negative. Negative square root of 2 plus square root of 2. Okay? It's a little complex, but this is a parabola when you have a squared. And what does this squared look like? Our old quadratic equations with squared. And when you have an equation that was y equals 3x squared plus 4x plus 1, then it looks like this, but it crosses the plane. So it's like this. You see? So, and where it crosses, that's where x equals 0 or y equals 0. So y is this one and x is this one. So when y equals 0, we have 2 answers for x. And that comes from solving this equation, factoring it and finding out what x is, either from guessing or from using the quadratic equation, quadratic formula. And then you have where your crosses and a parabola. That's where graphing comes into play. This is still linear algebra, but what calculus is all about derivatives. So it is y prime equals dx by dy. And what a derivative is a slope. So it's a slope. So if you take this point, the slope is tangent. So it's like this. It's a line where the area over here is equal to the area over here. So it's like this. So the slope at this point is like this. It's steeper. And the slope is always a line. It's always a line. So it's going to look like something like this. It's going to look like that. So it's basically still graphing, but you're graphing a slope. And you can calculate the slope at each point by a method of rules for every equation you find. So you just take this side and you apply some rules, and you'll find out what the slope is. I'm not going to go over them, but that's what your calculus is. Calculus is the slope of these graphs. Okay? So that was calculus. Now, the last chapter in all of mathematics is trigonometry. So, trigonometry. And that is triangles, in particular right angle triangles. This means this is 90 degrees. Now all angles in a triangle add up to 180 degrees. And the side opposite the right angle is the hypotenuse. So that's H, this is A, and this is B. So all angles add up to 180. This is already 90. So these two have to add up to 90, because 90 plus 90 is 180. And the other law is A squared plus B squared equals H squared. A, B, H. And then we have our functions. Sine, cos, tan. Cos means close. Sine means far. And tan means tricky. So cos is close. So if we were to take this angle and we say cos A, so A is the side. So cos theta, that's theta, and that's A. So cos theta is close, so it's equals A over H. Okay, so cos theta equals A over H. That's A and that's H. Now we say sine theta, that's far. Far is B. So B over H. So you have this over this, and you have this over this. So cos is the close one over the hypotenuse, and sine of this angle is the far side over the hypotenuse. And then finally tan theta equals, so tan of this angle is tricky, which is far over close. B over A. There's no H. It's just B over A. So tan of this side is B over A. Tan of this angle is A over B. Tan of 90 is infinity or 1 or something like that. It's messed up. You don't ever do this angle. You only do this angle or this angle, because this angle is 90. And I'll show you why. That's half of trigonometry. The other half is the graph. So 1, -1. Cos and sine are sinusoidal waves. So this is a sinusoidal wave. Okay, it goes on forever. It alternates between 1, -1, and it crosses 0 here, 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 here. And the only thing we are interested in is the frequency. So how long is this? 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 And the answer can be either in degrees or in radians, which is in terms of pi. And one cycle, so boom, 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 that's one cycle, is 2 pi always. Which means half a cycle is pi. Which means a bottom is 3 over 2 pi. And here is 1 over 2 pi. 1 over 2 pi. So one cycle is always 2 pi. That's the definition of sine and cos. And the top is 1, the bottom is 1, and you can modify these waves. So you can stretch it. So one cycle is not 2 pi, but maybe one cycle is half a pi. Or you can minimize it, so one cycle is 6 pi or 10 pi. But the standard default is 2 pi. And you can also make it bigger and smaller. So instead of 1, this is 10 and minus 10. You can also shift it up and down or shift it left and right. And playing with these waves is all of engineering is about. Because what is this? This is alternating current. Current goes up, current goes down, current goes up, current goes down. Current goes positive, current goes negative. Voltage goes positive, voltage goes negative. Or it's a mechanical wave, a light wave, or a sound wave, or a wave on the water, or some sort of wave, right? So physical wave, or it's an electrical signal. And what you do is then you play around with the graph and what the actual thing is. So example, 6 cos 10x plus 5 pi. So you'll have this, 6 cos 10x plus 5 pi. Except we don't use x's and we say WT and radians. That we use different variables in engineering, but example is this. Okay? And you'll draw that. You won't actually draw it, but if you were to draw it, it would look something like this. And then you play with it. Okay? So, and the difference between a cos and a sine. So this is a sinusoidal wave. A cos wave is the exact same, but it starts at 1. So it starts at 1 and then it goes like this. Okay? So a cos wave is the exact same as a sinusoid, except it starts at 1 and a sinusoid starts at 0. Once again, you can shift them, you can modify them, you can do whatever you want to them. but the basics of a sinusoidal and a cosinusoidal wave are they alternate, they go on forever, they go between 1 and -1, and one cycle is 2 pi, which is 360 degrees. So 360 degrees, right? And then it repeats. So if you were to find out cos of an angle, the answer is always in between 1 and -1. Or sine. So every single angle in the history of Earth, because the angle goes from 0 to infinity. This timeline is infinity. The standard basic sine or cos of any angle, either towards -infinity or positive infinity, is always in between 1 and -1. Never bigger than 1, never smaller than -1. And that's sine and cos. Okay? So there you have it, ladies and gentlemen. We had trigonometry. We had calculus. And lastly, we had algebra. So algebra, calculus, and trigonometry. Playing with equations, graphing the equations and taking the derivative and the slope, and using sine, cos, and tan, and triangles and angles and alternating current waves. That's all of mathematics. Right there, wrapped up in a neat little 40-minute video. Learn, study, share it with your pals, and good luck in mathematics. Peace.